Leave a nail outside for a year and it turns to crumbling orange dust. Leave a car in the rain for a decade and rust eats through its frame. Iron and oxygen are old enemies. Given time, water, and air, iron always loses, except it seems once. In the heart of Delhi, inside a quiet courtyard, stands a pillar of solid iron. It rises over 22 feet into the sky. It weighs more than 6 tons. It has stood in the open air, exposed to sun, rain, and wind for over 1,600 years. It should be gone by now. A pile of rust and memory, it isn't. Scientists thought the answer would take weeks to find. Instead, more than a century later, researchers are still arguing over parts of it. So how did a civilization working without electricity, without modern chemistry, without a single machine we would recognize today, build something that modern steel struggles to match? Was it forgotten technology, extraordinary skill, pure luck, or something we're only now beginning to understand? To understand the mystery, you have to see the pillar for what it actually is. It stands in the Qutb complex in South Delhi, surrounded by the ruins of a much later mosque. Tourists walk past it every day, often without realizing what they are looking at. The pillar is made almost entirely of wrought iron, not cast iron, not steel, a softer, purer form of the metal shaped by hand. It stands about 7.2 meters tall, roughly the height of a 2-story building. Its weight is estimated near 6,000 kilograms. That's heavier than an adult elephant. Historians date it to around the 4th or 5th century CE, placing its creation in the Gupta Empire, a period so rich in science, mathematics, and art that historians often call it India's Golden Age. An inscription on the pillar honors a king remembered as Chandra. Most historians believe this refers to Chandragupta II, one of the Gupta Empire's most powerful rulers. The pillar wasn't built as a monument to rust resistance. That wasn't the point at all. It was likely raised as a flagstaff, possibly topped once with a statue, and dedicated in a spirit of religious devotion. Nobody who forged it was trying to make history. They were just trying to build something that would last. They succeeded beyond anything they could have imagined. But that success raises an uncomfortable question. If ordinary iron rusts away in decades, how did this pillar outlive empires? To understand why the pillar shouldn't have survived, you first need to understand why iron rusts at all. Think of iron atoms as tiny magnets, desperate to bond with something. Left alone in the open air, they react with oxygen and moisture. This reaction creates iron oxide. We call it rust. Rust isn't just ugly, it's destructive. Unlike some other metals, iron's rust doesn't form a tight protective seal. It flakes, it crumbles. Each layer that falls away exposes fresh iron underneath, ready to rust all over again. That's why an untreated iron object left outside doesn't just get a little rusty. Over years, it can disappear entirely, eaten from the outside in, one layer at a time. Delhi's climate makes this even more surprising. The city experiences a punishing monsoon season, months of heavy rainfall followed by intense summer heat. This is not a gentle, dry environment that happens to preserve metal by accident. This is exactly the kind of climate that should destroy iron quickly, and yet if you walk up to the pillar today, you'll see only a thin, dark, remarkably stable surface. Not the flaking orange decay you'd expect, not after 16 centuries of monsoon, so either the ancient smiths who built it broke the rules of chemistry, or they understood something about iron that took modern science until the 20th century to rediscover. The real answer began to emerge only when scientists finally analyzed the metal itself, layer by layer. The first clue was the iron's chemical composition. Modern testing revealed the pillar contains an unusually high concentration of phosphorus, far more than typical iron of that era, and dramatically more than the iron we use today. At the same time, researchers found extremely low levels of sulfur and manganese, impurities that in most iron tend to accelerate corrosion. This combination turns out to matter enormously. Here's a simple way to picture it. Imagine building a brick wall. If you use bad mortar, water seeps through the cracks and slowly destroys the structure from within. High phosphorus iron behaves differently. Instead of creating cracks, it helps form a tight, adhesive barrier on the metal surface, one that seals in the iron underneath rather than letting moisture attack it directly. That barrier has a name. Researchers call it the passive protective layer, and it's sometimes referred to by the more specific mineral name misoite, after the scientist who helped identify its structure. Unlike ordinary rust, which flakes away, this layer bonds tightly to the iron surface. It thickens slowly over centuries rather than falling apart. In a strange way, the very process that should have destroyed the pillar helped seal it instead. But chemistry wasn't the biggest surprise. The real shock came when researchers realized how the pillar had actually been built. The pillar's construction method mattered just as much. Ancient Indian smiths didn't melt the iron into liquid form the way modern steel mills do. Instead, they used a technique known as forge welding. Small looms of iron, roughly the size of a large loaf of bread, were heated until glowing, then hammered together over and over, layer by layer, fusing into one solid mass. This process wasn't just labor-intensive, it was precise. Each hammer strike had to bond the layers evenly without trapping air pockets or weak seams that could later become entry points for corrosion. Building a 6-ton column this way using only manual labor, hand tools, and furnace heat represents an extraordinary feat of engineering discipline. Modern metallurgists studying ancient Indian ironworking have called it one of the most sophisticated applications of pre-industrial metallurgy anywhere in the ancient world. And then there's Delhi's climate itself, playing an unexpected role. Alternating dry and wet seasons actually help the protective layer form and stabilize over time, rather than constantly washing it away. In a permanently damp environment, this process might never have taken hold. In a bone-dry desert, it might not have needed to. 3 factors: the iron's unusual purity, the skill of the forge welding, the rhythm of Delhi's seasons. Individually, none of them fully explain the pillar's survival. Together, current evidence suggests they created something close to a perfect, if accidental, formula for corrosion resistance. Whenever science can't immediately explain something, myths rush in to fill the gap, and the iron pillar became a magnet for them. Naturally, a mystery this striking has attracted more than just scientists. Over the decades, some claims about the pillar have drifted far from the evidence. You may have heard that the pillar was forged using lost technology beyond anything humans could achieve today, or that it was somehow connected to extraterrestrial visitors, or that it possesses supernatural, even magical properties. These ideas are understandable. When something this old defies expectation this dramatically, mystery tends to fill the gaps where explanation is missing. But it's worth being honest about what the evidence actually shows. There is no reliable archaeological or scientific evidence supporting alien involvement or supernatural forces. None of the peer-reviewed metallurgical studies conducted since the 20th century have found anything inconsistent with human ironworking of the period. What the evidence does show is arguably more impressive. Real people using real tools, real fire, and generations of accumulated metallurgical knowledge created one of the most remarkable examples of pre-industrial ironworking ever produced. There's also a popular legend that the pillar was originally located elsewhere, possibly moved from a mountain or a distant kingdom. Historical evidence for its exact origins before installation in Delhi remains genuinely limited, and some details of its early history are still debated among historians. That uncertainty isn't a weakness in the story, it's simply where honest history has to admit its limits. So, the pillar isn't magical, it isn't extraterrestrial, it isn't proof of some vanished supercivilization with technology beyond our own. It's something else. Proof of what skilled human hands, patient craftsmanship, and generations of trial and error could achieve long before anyone understood the chemistry behind their own success. In some ways, that's a far more remarkable story than any myth could offer. Here's the part almost nobody expects. This ancient pillar isn't just a historical artifact, it's helping engineers solve modern problems. So why does a 1600-year-old pillar still matter to scientists and engineers today? Corrosion isn't just an ancient inconvenience, it remains one of the most expensive problems in the modern world. Corrosion damages bridges, pipelines, ships, and infrastructure, costing economies hundreds of billions of dollars every year in repairs and replacements. Modern engineers have studied the iron pillar of Delhi specifically to better understand natural corrosion resistance, hoping to apply similar principles to protecting steel structures today. Its high phosphorus composition has informed research into low corrosion alloys. Its passive oxide layer has been studied as a natural model for protective coatings. Even its shape and mass have been analyzed to understand how large-scale metal structures behave over long timescales exposed to weather. The pillar stands quite literally as a bridge between ancient metallurgy and modern materials science. It reminds engineers that some solutions were being explored empirically through trial and observation centuries before anyone had the chemical vocabulary to explain why they worked. It's also a powerful reminder of the depth of ancient Indian scientific achievement that existed alongside remarkable advances in mathematics, astronomy, and medicine during the same era. The pillar isn't just a curiosity, it's evidence. But perhaps the most astonishing part isn't that the pillar survived, it's that the ancient craftsmen who built it almost certainly had no idea why it would. They discovered the formula through experience, not chemistry. Centuries later, science caught up. So how did an iron pillar built over 16 centuries ago survive with almost no rust? Not through magic, not through lost alien technology, not through forces science can't explain. The most defensible answer, supported by decades of careful research, points to a convergence of factors: iron, unusually rich in phosphorus and low in corrosive impurities, forged by hand with extraordinary precision, allowed to develop a thin, stable, self-protecting layer on its surface in a climate that happened to support rather than destroy that process. Some details remain debated. Historians still discuss its exact original purpose and early history. Metallurgists continue refining exactly how much credit belongs to composition versus craftsmanship versus climate. But the broad picture is clear, and it doesn't need embellishment to be extraordinary. Somewhere nearby, modern iron fences slowly rust away. Yet only a few steps from them stands a pillar that has watched 16 centuries pass. Sometimes history doesn't survive because of luck. Sometimes it survives because human ingenuity was far greater than we ever imagined. Sometimes the greatest mysteries aren't magic. They're achievements so far ahead of their time that they continue to astonish humanity more than 16 centuries later.